So hey guys, welcome back. In this video, we're gonna see this Leetcode problem named as the power of 2. So this is quite easy Leetcode problem. We will be giving an integer and we have to decide whether that integer is a power of 2 or not. Let's just understand with some visuals. So here I have just written some sort of presentation for you. There are many methods. So there are a couple of methods around here you can easily find on other YouTube videos, but the most efficient method I would say is what I'm going to tell you. So let's see, just power of 2 means if we have this 2, then 2 to the power 0 is equals to 1. Then 2 to the power 1 is equals to 2. 2 to the power 2 is equals to 4. Then 1, 2, 4, 8, and 16. These all are the values that are the power of 2. Now, the easiest way to solve this problem is through the bitwise operation, right? So if I just write this, that the power of 2, this is called the 1. So if I write 1 in terms of binary digits, so we have 0 and 1. If I write 2, then in terms of binary digits, we have 1 and 0. To tell you 4, so you can see this is 100. If I talk about 8, then it is 1000. If I talk about 16, it is 10000. So these are the 4 zeros and the only 1. So you can only see that in terms of the power of 2, there is only one bit, exactly only one bit that is set to 1. We can clearly see here there is only 1, 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 and the remaining are only zeros. How we will gonna proceed with this problem? Just using the bitwise AND operation. So let's say this 8 is the power of 2. You can clearly see that 2 to the power 3 is 8. If I write this 8 in terms of the binary numbers, so it is 1000, right? And if I just minus this one, what I'm using here, I'm just going to tell you, I'm using this, that n. If I say the given number is 8, right? So I'm using this 8 as an example, and I'm using the AND operator, and I am using the 8 minus 1. What I'm doing, so what I've done here, I'm just doing this 8 and 8 minus 1, right? So here what I have to do, we have to just check this, that this 8 and 8 minus 1, that is 7. So 8 minus 1, that is 7. So we are using the 8 and operator, 8 bitwise AND operator, and using the 7. So what here, you can see, if you can look at here clearly, then you can see that if I apply this AND operation in these two numbers in terms of the binary numbers, so you can clearly see if I just AND these two numbers only, so 0 and 1, what it will be called, 0 1 0, right? If I just take this 0 and this 1, then 0 and 1 0. If I tell you this 0 and this 1, then 0 1 0. If I tell you this 1 and this 0, then this will be also 0. So the final answer that you will always have is 0. Again, if I just demonstrate you with this example, here I have taken 16 and 15. So if I just compare this 0 with this 1, so 0 1 0. If I take this 0 and this 1, then 0. If this 0 and 1 0 0, and in the last this is another 0, right? So the final answer that you have is 0. So these are the numbers that were the power of 2. So 16 and 8 were the power of 2. In that case, I used that logic. So if I have been given a number like n, right, and if I use the AND operator, the bitwise AND operator, and I just decrement its one value, and I just use the AND operator with that, then I will surely get the answer 0. And if I get the answer 0, in that case, this n is the power of 2. But if I take this example, let's say you have been given 10 as the integer, right? So if I use this 10 here, you can clearly see this is the 10, right? And we have this 9. So if I compare this 0 1 0 1 0 0 0 0 0, but what is this 1 1 1? So you can clearly see that this is equivalent to what? Is equivalent to 8, right? But so this is clearly means that this is not equals to 0. So this 10 is not a power of 2, and we all know that 10 is not a power of 2. So this is how I use this approach in this problem. You need to know that if the given number should be greater than 0, right? It should not be greater than equal to 0, because 0 is not a power of 2, right? So it should be greater than 0, and also we need to check this condition, right? So how are we going to implement this? Let's just see. I am writing this code. And the first condition that we need to check is that whether the given number or the integer is less than or equals to 0, right? So if it is less than equals to 0, then we will surely return false, right? Or else we just simply return the result that n ANDed with n minus 1 should be, I'm just putting them all together in a single bracket, should be equals to 0, right? So sorry, should be equals to 0, like this, right? So I've just exactly applied this, that this n, when ANDed with its lower number, then it should be equals to 0, that we proved here in these 3 examples. So I just implemented the same thing. So let's just run this. So you can clearly see that our test cases are being passed, that in case of 3 it is returning false, in case of 16 it is returning 2, in case of 1 it is returning true. If I just shorten this thing, so I can write it in a single line. So how can I write in a single line? Like this: if n is greater than 0 and n minus 1 is equals to 0, like this. If this condition is true, if n is greater than 0, true, and if this is also true, then the final returning value will be true. So if I talk about the time complexity of this algorithm, then the time complexity of this algorithm, since there is no loop, there is no other things, so the time complexity will be constant. And the space complexity, since we are not using any kind of additional space, so the space complexity will be O1. So the time and space complexity will be constant in this case. So this is the power of 2 Leetcode problem. I hope you understand this, and if you have any queries, so you can definitely ask in the comment section. Thank you so much.